9-7, similar and congruent figures. What I want you to do is go ahead and hit pause and copy down this information. So go ahead and do that. Alright, looking at similar figures, it says figures with the same shape but not the same size. That is what a similar figure is. So again, they're the exact same shape. This is an obtuse triangle. This is also an obtuse triangle, but not the same size. This one is obviously larger than this triangle. Okay. Now, congruent figures are figures with the same shape and same size. So in this case, we've got a square and another square, and they are exactly identical to each other. Exact same shape, exact same size. So that's the difference. Similar just means that they're almost the same, not exactly the same, like congruent. Okay? They're the same shape, but they are not the same size for similar figures. So let's look at the next one. And it says corresponding sides. It says that would be the sides of congruent or similar figures that match. Okay? So it's going to be the sides of a congruent or similar figure that match up. So as we look at this, it says the corresponding sides would be segment AB, which is this blue one, is congruent to XY. Okay, this one right here, or correspond, sorry. They correspond to each other. Okay, they're going to be that same side of the triangle. In this case, these two particular shapes are not congruent, they are similar. So let's look at the next one. Segment BC, which is the red one, corresponds to segment YZ, which is this red one. And then we have segment AC, which is the green. It corresponds with segment X and Z. Now, it also says because these are similar figures, their sides are proportional, meaning that the corresponding sides will have a constant ratio. Okay? So because sides are proportional, meaning that corresponding sides have a constant ratio, we're looking at, and again, what is a constant ratio for the set of triangles? The question that they're asking. See how these match up? You have segment AB, segment XY. The length of this triangle is 6, and this segment XY of this similar triangle is 2. Okay? Well, reduce that. What is the difference? Well, if we divide both of them by 2, that ratio, it is 3-to-1 ratio. Basically, it is divided by, or we can divide by 3 if we're getting smaller, or we can multiply by 3 for getting larger. Now let's see if that is the same case for segment BC, which is 9, and YZ, which is 3. You reduce those by 3, and you get 3/1. So again, divide by 3, the same number, and you get the smaller number, or you can multiply if you're going to the larger triangle to get that. The next one would be 12/4, which equals, again, if we're dividing this by 4, you can reduce that and get 3/1. Okay, and again, simply multiplying by 3, you can see all the constant ratios. That's what they're asking, what the constant ratio is. They're all 3-to-1 ratio. So look at each one of these. Pick one. 6 and 2, they're corresponding. Divide those by, how is 6 becoming a 2? Well, you're dividing by 3. So can you divide by 3 with each one of these and get the same answer? This one is 9 divided by 3. That gives me 3. and 12 divided by 3 gives me 4. So that's how this is a constant ratio. Okay. Basically, for these, you're trying to get these all equal to a number over 1. And if they're constant, the numerators continually being the same, then that would give you a constant ratio. Let's look at this next one. It says determine whether the figures are congruent, similar, or neither. Well, again, is this rectangle? I'm going to let you do this. So go ahead and do letter A. If you want to hit pause, you can do so and see if you can get the same answer. So go ahead and hit pause. All right, it says determine whether each figure is congruent, similar, or neither. In this case, since they are the exact same size and same shape, then it would be congruent. Okay. Go ahead and hit pause if you haven't done so and solve letter B. So now, are these congruent? Are they the same shape? And they are not. The next question is, are they similar? Do they have the same shape, but not the same size? And in this case, this would be an equilateral triangle. Is this an equilateral? I don't believe it is. One good reason to note is that that is a right triangle. That is a right angle. This is not. So in this case, it would be neither. Okay. Now looking at this one, a six-sided figure, the hexagon. So now we're looking to determine, are they the same shape? And yes, they are the same shape, six-sided figure, and regular, and a hexagon. So therefore, we want to see if they're the same size, and they are obviously not the same size. Therefore, this would be similar. Okay, let's look at the next one. It says which triangle or triangles is similar to triangle DEF? And again, this would be triangle DEF. So we're trying to determine if it is the same or if it is similar to this particular shape. And again, are we, when we're talking about a similar figure, it's a matter of determining whether it is the same shape, not necessarily the same size. So immediately we see that it has a right angle. So look, do the rest of them? Yes, they do. I'm going to let you go ahead and hit pause and see if you can identify which one of these three is similar to this shape. So go ahead and do so. All right. Since we don't have anything to go by other than the numbers, that's what you're going to want to look at. And again, we looked at the angle. They both, all three of them have right angles. So let's look at the sides and see if they correspond. So we're going from a 6, and this one is a 5, so it decreased by 1. My 8, if I were to decrease that by 1, it would have to be a 7. So this one is a 12, so this one is not. So let's try this one. We're going from a 6 to a 3. So we divide, it's half of it. We're dividing it by 2. And for the 8, we're going from 8. If we're going to divide that by 2, then we'd have to get 4. And yes, we do. We get a 3 and a 4. Okay. So far, that one looks like that one will work. Going from a 6 to a 9. So again, we're looking at a ratio 6 to 9. That is getting larger. And then we have an 8 to 12. And if we reduce this to see if the ratios are congruent, we divide this one by 3 and get 2/3. This one we'd have to divide by 4 and we get 2/3. And so that one also would give us congruent ratios. This one we said is a yes. And is this one congruent? Or excuse me, is it, yeah, I guess we should say congruent. Is it similar? Are these two congruent? Yes, they are. They're equivalent. So the ratios are constant. So therefore, this one would also work. This one over here, the reason it did not, again, looking at the ratios, 5/6 and then 8/12, which this then reduces to 2/3. Okay, this ratio is reduced, this one is reduced. They do not match up. That's why that one is incorrect. Forgot to go over that with you. For these here, again, we can divide by 2 and we get the same. Let's check it again to where we have 6/3, which that was going to give us 2/1. And for this last one, 8/4. Divide by 2, and we get 2/1 for that as well. It's always good to make certain that you do that because some of them are not as obvious. Looking at this first one, knowing that we could divide it by 2 for each one of them, we knew that we could end up getting the same ratio. However, for this one, you end up getting, it's not going to be a number over 1. As long as they're the same ratio reduced, then you're fine. So that's why this one is not nearly as obvious, but they are still considered similar. So we have to be very careful with that. We'll take a look at this again tomorrow. So hopefully this has a little better understanding on the ratios and finding that constant ratio to determine whether they are similar or not. Have a great night, and we'll see you tomorrow.